Hello, Professor Simpson here, back with our second video of Chapter 12, Section 3. In this video, we will focus on the third law of thermodynamics and calculating entropy changes from standard conditions. My apologies, the first videos from this section got a bit long. There's just a lot to walk through here as we talked about the second law of thermodynamics and this idea of change of entropy of the universe. Hopefully, as we walked through this, it made sense as we saw the relationship between change of enthalpy of the system with regards to the change of entropy of the surroundings, and then the change of entropy of the system plus change of entropy of the surroundings gives us a change of entropy of the universe. As I said in that first video, it's good for us to be able to know that without doing any calculations, that we have a circumstance in which we are always spontaneous. We have a circumstance in which we're never spontaneous. But we still have more work to do here in the middle in these two types of reactions. So we're going to talk a little bit about some calculations that can help with that here in this video, but really we'll get into what we need to do in these circumstances when we get to the next section, 12.4. In the meantime, let's talk a bit about the third law of thermodynamics. You can see here the definition. The entropy of a pure, perfect crystalline substance at 0 Kelvin is 0. So there is a point in which there's no entropy, and that's the point where we reach the lowest possible temperature of absolute zero, which is 0 Kelvin. At that point, there's no molecular movement, so we can say that the entropy becomes 0. And because of this, we can then determine standard entropy values for different substances. And you will see them listed in a table like this. So if I have these standard entropy values, you will recall earlier in the course, we calculated the standard enthalpy values from the enthalpy of formation in a chemical reaction. That process was, or that formula was, it was the sum of the enthalpy of formation of the products minus the sum of the enthalpy of formation of the reactants. Similar process is going to occur here. We're going to get the data here of entropy values, standard entropy values, and it's going to be, once again, the sum of the products minus the sum of the reactants. So if I were to take a look at this reaction based on the values given in the table, I could set this up pretty easily. Again, it's the change in entropy, standard entropy, is going to be the sum of the products minus the sum of the reactants. So for my products, I have 2 H2O liquid, and I can see that value listed in the table, minus the sum of the reactants, which I have 2 H2 gas plus the value for the O2 gas. Again, as I work through that, I would get a final answer here of negative 294.7 joules per mole Kelvin. Now, we would have predicted by looking at the states here that a reaction that goes from a gas to a liquid is a decrease in entropy. But we saw before where that may not be enough to tell us whether or not the reaction is spontaneous. So I need to start to get some actual values here for the delta S of the system and the delta S of the surroundings to see truly if the delta S of the universe is positive or negative. So here is one way in which we can do that. And now we have a value for the delta S of the system. Now that we have seen how to calculate that standard entropy change, if we think back to the fact that we can also calculate the standard enthalpy change, we could do both of these calculations if necessary to get those enthalpy and entropy values of our system. So you should be prepared if given a table with enthalpy and entropy values to be able to calculate both of those values out if need be. Okay, so that wraps up this second video. This was a quick one, this second video here for section 3. So at this point, if I look back at my learning objectives, I should be able to state and explain what the second and third law of thermodynamics are, and how to walk through all that that we talked about in the first video, and then also being able to do these calculations of the standard entropy change here in this second video.